Okay, so today we are going to look at combining functions. First, we're going to look at it in arithmetic way, so just the arithmetic of it. Uh, so just like two real numbers can be combined by operations such as addition, subtraction, multiplication, and division to form other real numbers, two functions f of x and g of x can be combined to create new functions using addition, subtraction, multiplication, and division. The domain of the new function will be the overlap of the domain for uh the domain of the new function is the overlap of the domain of the original two. So if one domain was, say, all real numbers, and then the other domain was restricted to, like, say, x is greater than 2, the overlap of that would just be x is greater than 2. So if you see one has a more restrictive domain, most of the time that's going to end up being the domain. We don't have to stress too much about that, actually. Uh, we're just going to focus on how do we combine them right now. So those of you that just got in, we just started the notes. I have fixed your attendance, so thank you for being here. Okay, so let's look at what that all means. So let f of x and g of x be two functions with overlapping domains. Complete the following combinations. So the sum is adding them together, difference is subtracting them, quotient will be division, and our product just multiplying them together. So here with this, I'm given these two functions, f of x and g of x. I don't have as many color options on Zoom as I do on Smart Notebook. So product, I'm probably going to do in black, even though I initially had set the color as purple. So here with this, f of x plus g of x. So we're just going to write them down. 2x minus 3 plus x squared minus 1. This is just a matter of combining like terms. It's all we have to do here. Nothing combines with the x squared, so x squared. Nothing combines with the x, so that's still going to be a plus 2x. The minus 3 and minus 1 are the only like terms we have. Negative 3 minus 1 is a negative 4. And that's it. That is finding our sum here. The difference, all we have to do is just be careful with the minus sign. So what I have to do here is say 2x minus 3, and minus, I'm going to put all of g in parentheses. So then I would have to distribute this negative, giving me let's start with writing the first part. 2x minus 3 minus x squared, and then negative and a negative 1 flips that to a positive. So again, just combine like terms. Nothing combines with the x squared, so negative x squared. Nothing to combine with the 2x, so just plus 2x. However, the negative 3 and plus 1 can be combined to give me negative 2. I'm just going to leave it as that. Product. For the product, you're just going to put them both in parentheses. So 2x minus 3 times x squared minus 1. Now, the goal with the product is just going to be to use the distributive property. So you can look at this as a double distribution or a FOIL type problem. And that's all we're going to do. If it happened to be a trinomial behind here, it just gets multiplied out a little longer. If in IM3 you were using the box method, to multiply. I know we covered that pretty heavy. Those of you that were in IM3 last year with myself or Mr. Thompson, we covered the box method pretty heavy. If you prefer the box method to multiply, go ahead and use whatever way you like to multiply. I'm just gonna do it just with distributing. So 2x times x squared, that gives me 2x cubed. 2x times -1, -2x. Going through this in the same order we would do FOIL in. -3 times x squared, -3x squared. -3 times -1 is +3. There is one minor rewrite that most people would tend to do here, and that would be to simply flip the -3x squared and the 2x, because usually we like them in descending order. So I'm going to just quickly do that. So that also equals 2x cubed minus 3x squared minus 2x plus 3. And that's our answer. Now, quotient, writing it, division. That one may seem like, oh, geez, that seems like it can be a lot of work. Well, we'll learn how to divide polynomials later. So for right now, all I want you to do is be able to put f of x in the numerator over g of x in the denominator. And we'll just stop right there for the quotient rule. So that is our sum, difference, product, and quotient. I'm not seeing anything in the chat right now question-wise, but I do want to take a pause for you for questions right now. And I am just going to do, while I'm pausing for questions, I'm just doing a quick scan of attendance, make sure those marked absent are the ones that are still just not here yet. I think I got everybody. Yes. Okay. I'm not seeing any questions popping up. If you would like to unmute yourself, you can also unmute yourself for questions. Clear that. Okay. Next part of the notes deals with evaluating these. So there are two ways to do this. I'm going to first do it by combining the functions. Then I'm going to find f minus g of 4. The second way is to evaluate what f of 4 is, what g of 4 is, and then subtract those. At the end of the day, both methods are equally valid, and it will not affect your answer which way you do it. So whichever way seems best for you, go with it. So here with this, I'm going to do 7x minus 5 minus the quantity 3 minus 2x. Distribute the negative, and we'll get 7x minus 5 minus 3 plus 2x. So I got the x's to combine, and I got the numbers to combine, or the constants to combine, I guess would be the better way to put it. 7x plus 2x is 9x. And then -5 minus 3 is -8. So what I can do now that I've combined these, it says f minus g of 4. What I could do is just plug 4 in for x. So 9 times 4 minus 8. 9 times 4, let's see, that's 36. 36 take away 8 should be 28. Okay. That's the first way to do it. If you like that way, you're like, that was easy enough. I don't even care too much what the second way is. That's easy enough for me. Great. If you're like, oh, I still want to see the second way, that's fine too. So let's take a look at this other way we can handle this. So the second way would to be find f of 4, g of 4, and then subtract them. So I'm going to do 7 times 4 minus 5. Let's see, 7 times 4, that's 28. 28 minus 5 is 23. Okay, let's see what we get here. 3 minus 2 times 4. 2 times 4 is 8. 3 minus 8 is negative 5. Could now do 4 minus g of 4, which is the same as saying 23 minus a negative 5. So negative turns into a plus, so that's 28. Notice, no difference in the answers. Some students may say, hey, the first way makes a lot of sense. Some people might say the second way is what makes sense to them. At the end of the day, you're accomplishing the same goal. You're still doing well with it. And, it's the same idea. 1 second, somebody sent me a message on Schoology. I just want to quickly get back to them. It is not related to the lesson, so while I'm replying to them, just think if you have any questions, unmute yourself or put them in the chat, please. So again, I don't care which way you prefer to do it. If one thing I will say, sometimes I prefer the first way more if I'm having to use like f minus g a few times. That first way can be very helpful because then it's just, oh, I got my new equation, just keep plugging into that. Where if I needed to do like f minus g of 4, f minus g of 5, f minus g of 6, it's one of those things that you'll just have to keep plugging in multiple times. So let's clear that. I'm not seeing any questions popping up and move on to the next part. So the next part talks about composition of functions. And again, the composition will be the domain, will be the overlap of the original domains. So a lot of times we'll write it in this FOG form, which is just a fancy way of saying f of g of x. So if it has that little O between them, the function that comes first is the outer function. The function that comes next is the inner function. So what we're essentially going to be doing here is replacing x with an entire function. So here we're going to do this both ways. I'm going to do f of g of x, then I'm going to do g of f of x. So here's how example A is going to go. So what this is actually saying is f of g of x. So notice how g of x is inside where the x was. What we're going to do is where we see x in our f function, we are going to replace that with the entire g function. So we're going to replace x with 2x squared minus 1. So let's get going and see what this will look like. So this is going to be 3. Now I'm going to use parentheses since it says x. I now replace that with g of x. 2x squared minus 1. Basically, all I'm doing is substituting this in for x for part A. And then keep it going, plus 4. Now all we have to do is simplify from here. Start with distributing the 3. So that will give me, not 3. 3 times 2 will be 6x squared minus 3 plus 4. Well, negative 3 plus 4 is just 1. 6x squared plus 1. And that's it. Now, the next one going the other way is going to be slightly more complicated because we're having to plug in where it says x squared. So let's take a look at that. Or actually, first, do we have any questions on part A? Not seeing any questions in the chat, and nobody is a Sorry about that, guys. I don't know what happened. It just kicked me out for a quick second. So I'm just going to do part B where we left off. So just pulling up the notes right now. There we go. Okay. So now I'm trying to do for part B. Again, you had the full completed version of these notes on Schoology. I'm doing G of F. So wherever I see X, function G, I'm going to replace it with 3x plus 4. So let's start writing this. It starts off with 2, and then it says x, but remember instead of x, I need to plug in f of x. So I'm going to plug in 3x plus 4, and I'm going to square that, and then minus 1. So what we have to do here, I'm going to remind you when something's squared. So for this part, I can take that work over here and be like, oh, this is 3x plus 4 times 3x. Let me erase that arrow so I have room to write. 3x plus 4. So when I FOIL this out, that's going to give me 9x squared plus 12x plus another 12x plus 16. And then I combine that, so it gives me 9x squared plus 24 plus 16. So in reality, this ends up being 2 times 9x squared plus 24x plus 16 in parentheses minus 1. Distribute the 2 here, and that will give me 18x squared plus 24. No, not plus 24x. Multiplying by 2. 48x plus 32 minus 1. 32 minus 1 is the last thing to combine. 18x squared plus 48x plus 31. Okay, I know that one was a lot more work than the other one. It's okay. It's just getting used to those. And essentially, if you think back to either Algebra 1 or Integrated Math 2, whichever you took, when you learn the substitution method to solve, this is very similar to that, where, oh, we know it's equal to this, so we're just plugging it in. That's what we're doing here. We're plugging in a function for x. And when we plug that function in, sometimes things can get a little more complicated. But again, this idea may be new in its presentation, but you've actually utilized some of these skills in previous classes. So the idea we're talking about is new, but the skills needed for it are kind of just like old skills, just being applied in a new fashion. So remember, if the f comes first, that ends up being your outside function, and then g's your inside. If g comes first, like in this example, g is your outside function, f goes into the inside. So let's clear that and take a look at, I believe this should be our last example. Yep. Last example here is a word problem involving this. Okay. If the function f of x equals 0.6, x represents the sales tax owed on the purchase with a price tag of x dollars, and g of x, and the function g of x equals 0.75, x represents the sale price of an item with a price tag of x dollars on 25% off sale. Using one of the combinations of functions in this section, write the function that represents the sales tax owed after it's already 25% off. Okay, so for this, I'm wanting the sales tax of however much I spent. What I realize here is I would basically just want to put this in for X because that's my new price. So this ends up being F of G of x. So all I want to do is plug that in. So f, my outer function starts with 0.06, and then instead of writing x, I'm going to plug in my function g, 0.75x. Close this function. Okay, now all I had to do is 0.06 times 0.75, and that will give me what this is. So it gives me a final answer of 0.045x. So since we got 75% off, or sorry, we got 25% off, we're paying less in our sales tax. So we went from 6% to 4.5%, if we compared it to the original price. Uh, I'm back. I'm back. I'm sorry about that. My internet just kicked my device off for a moment. Um, I know we were looking at that last example. Do we have any questions for me right now, on this lesson? Let me go back to sharing. So I do just want to quickly talk about what problems were assigned. So here with this, we have, so I'll quickly go back and just give a summary of the notes in 1 second. And again, this is recorded to watch at a later time for anybody that needs it. So this is the homework. Please note in numbers 41 through 44, I am asking you to do all problems. And inside, I think, let me double check what problems it is. There are some problems that will ask you to do the addition, multiplication, or addition, subtraction, multiplication, and division of the two functions. So if it does ask for all four, please make sure you give me all four. Just don't give me the first one. So quickly summarizing what we did, I know, actually, wait, yeah. So like when I'm doing the sum, just look at that as combining like terms. It's all we have to worry about there. Same with difference. When I say the product, you'll put them both in parentheses and then essentially just multiply them. And then when we say quotient, all we're doing is dividing, so you will just divide the two functions. Oh, wait, it's just numbers 12 and 14 that you have to do all four. So do adding them, subtracting them, multiplying them, and dividing them. So with numbers 12 and 14, because you're doing all four operations, that's why I only gave you 4 problems to do out of that group. So I'm going to stop the recording for now. I will show you the work on the sum difference and quotient for those that need it. So stop